All right. Hey, everybody. So we have already looked at how to add and subtract matrices, and we have given you a brief overview, and introduction already. Well, now we're going to learn how to multiply matrices. So you might think, after we have learned how to add and subtract matrices, you might think that the same rules will apply for multiplying matrices. The rules for multiplying are very different. And once again, they are very specific. So with the addition and subtraction, you have the same dimensions on your matrices. Then you perform the actions with correlating values. So, for example, you would have the row 1, column 1, add with row 1, column 1 of your other matrix. This is very different than how we're going to do it when we multiply. So for multiplication, the only parts that need to match will be the number of columns in the first matrix and the number of rows in the second matrix. They don't need to have the same exact dimensions. Just the number of columns in the first one and the number of rows in the second one. So here's an example. If we want to multiply matrix A with matrix B, matrix A has dimensions 3 by 2, as you can see, 1, 2, 3 by 1, 2. And matrix B has dimensions 1, 2, 1, 2, 3, 4. We are allowed to multiply these matrices. They are compatible. However, you would not be able to flip them around. You could not multiply BA, you can only multiply AB. So because the number of columns in the first matrix, number 2, is equal to the number of rows in column B. If you were to flip that around, they do not match up anymore. And here is a way that we can think about how to do this. I have taken out the numbers. As you can see before, we have 5, 9, 5, 11, -2, -6. I've changed those just so it can help us think about what we are going to do to multiply these, because it's actually going to be quite a lot. So we have the rows of the first one are labeled, and we have the columns of our second one are labeled. I've given them all their own letter. Here is A, here's B, here is C, D, E, F, G. Notice that they don't match up. The A's are horizontal and the D's are vertical. That's very important. So what we're going to do is we're going to multiply the parts of row A with the parts of column D, and then we're going to add those together to give us a new value. So for example, we will multiply the A1 with the D1, as I did right here. Then we will add that to A2 times D2. Next, we will do it for each subsequent column with the same row. And this will give us our new matrix. It has the row value of our first one. So all of these are going to be put into row number 1 in our new matrix. And then this will be for column 1, this will be for column 2, this will be for column 3, this will be for column 4. You'll see it in just a moment. But so we just have to multiply the A1 and A2 by the D1, the D2, the E1, the E2, the F1, the F2, the G1, the G2, and we add our pieces together for each column that we do. So we do it again for the F1, or the Fs and the Gs, for the rest of the columns of the matrix, and then through the rows of our first matrix, until everything is completed, and it will look like this. This will be the sum of the products of multiplying row A with column D. This will be the sum of the products when you multiply row A with column E. So we have AD, AE, AF, AG. Then we go to our B's, BD, BE, BF, BG, CD, CE, CF, CG.